Hi all, let's start second session of chapter Electrostatics. So in last class we discussed about charging method of different bodies. First was because of friction, second was because of conduction, and third was because of induction. Okay, now, and I think I have given you one homework question. So let's start our class with that question. Yeah. So question was, now let me change my screen first. Yeah. So question was, two uncharged metal spheres A and B are in contact as shown in the diagram. A negatively charged rod is brought near to A but not touching it. The two spheres are separated slightly and the rod is then withdrawn. As a result of this, option A, both the spheres acquire positive charge. Option B, both the spheres acquire negative charge. Option C, A acquires negative and B acquires positive charge. And option D, A acquires positive and B acquires negative. Okay, so now it's a very clear that in this example, so basically we are using method of induction. So basically it's a negatively charged rod. So when we will bring this negatively charged rod near to object A, okay, so because of negative polarity, so all the electrons of this combination, the A plus B, actually initially they are touching each other. Okay, so all the electrons of this combination, they will be repelled, and all the electrons, they will move towards the opposite side, that is this one, this side. Okay, so finally we can say after some time, the right hand side it will be positively, you can say polarized, or negatively polarized, or we can say it there is a dominance of negative charge, negative polarity on right hand side, and on left hand side there will be positive charge. Okay, now the condition is that two spheres are separated slightly. So after some time we have separated them. After that we have removed that negatively charged rod. Okay, so we can see, if this is the case, then we can see B, it will acquire negative charge, and body A, it will acquire positive charge. So answer will be D. Answer is D. Okay, so I think all of you have attempted this question. Now let's move on. Yeah, so again using method of induction, again it's a very simple example. Again, this rod, it's negatively charged. Okay, so because of this negative charge, all the electrons, they will move away. So all the electrons, they will be shifted towards this direction, and there will be negative charge on left hand side. Okay, again it's a very simple example. So basically there are three methods of charging. First is by rubbing because of friction. Okay, now second is because of conduction, and third because of induction. So in first two method, let me write here. So we need physical touch. Then bodies need to be in physical contact actually. Okay, but in induction there is no need of physical contact. Okay, now next topic is gold leaf electroscope. So what is the meaning of gold leaf electroscope, and what is its significance? So basically it's a method, it's an instrument actually. It's an instrument used to check whether any object it is charged or it's neutral condition, in neutral condition. So basically in gold leaf electroscope there are two gold leaves. So you can see here, these are gold leaf. Okay, now let's suppose we want to check this object whether it's charged or not. So basically we have to touch this object it's test object. Okay, so basically what we have to do, so we have to bring the body near to the brass cap, this one, okay, or disc. Okay, now if the gold leaf diverges outward, why? Because when we will bring this test object near this brass object, there will be charge induced. Okay, clear? So charge will be induced, and on this one and on the other leaf, they will have same polarity of charge. And we already know, like charge, they will repel each other. Okay, now let's suppose this body, this object, it's neutral, then there will be no induction. Clear? So basically, it consists of a gold leaf attached to the brass disc, which is suspended with the help of a brass rod in glass jar. Okay, so basically, the function of this instrument is to check the polarity. Basically, I'm not saying polarity, whether the object is it's a charge or it's a neutral. Clear? Any doubt? Any confusion so far? Okay. So again, I'm repeating same thing. So in gold leaf electroscope, so when a negatively charged rod, we will bring it near to the brass cap. So positive charge, or we can say all the electrons, they will move towards this side. Okay, now it's carrying negative charge. Again, it's carrying negative charge. So because of this, they will repel each other. Clear? So by using method of induction, we can check whether the test object it's charged or it's a neutral state. Clear? Okay, so just give me 1 second. Let me start next topic. Okay, and next topic, it's a very, very interesting topic, and it's a very vast topic. It's a backbone of chapter electrostatics, that is Coulomb's law. I think most of you have heard about Coulomb's law. If not, don't worry, we will cover this topic today. Okay, yeah. So far, is there any doubt, any confusion? So far, we have got very basic topics of electrostatics. Now, we will rise our level. Okay. So there was a scientist named Mr. Coulomb, and he was a French scientist. Okay. Mr. Coulomb, he was a French scientist. Okay. So we don't need to focus on his history. So basically, we must focus on his learning and his experiments and his basically, you can say, experiments. Okay, and formula, the famous formula. Okay, yeah. So let's start our next topic. So basically, he has done couple of experiments. He had done couple of experiments. On the base of these experiments and the results of these experiments, so he gave a formula. Okay, and according to his experiments, let's suppose there are two charges of value Q1 and Q2. Q1 and Q2, and both are separated by distance d. Okay, now according to his experiments, force between, either it's a force of repulsion or it's force of attraction, force between these two charges, it's directly proportional to product of Q1 and Q2, and inversely proportional to the square of the distance between them. The square of the distance between them. Clear? So I think most of you know about this relation of inverse proportion. Okay, so he gave the formula, that is K Q1 Q2 divided by d square. And this formula is called Coulomb's law. Basically, it's a force of either it's a force of attraction or force of repulsion. Clear? Any doubt? Any confusion? Okay, so we don't need to go on we can say the setup and all. Okay. Yeah. So basically, this formula it was derived in 1785, and he has arrived at, we can say, inverse square law of relation, and this is known as Coulomb's law. Okay, Coulomb's law. Clear? So basically, we can say the force between two charges Q1 and Q2, the magnitude of this force, it is proportional to product of both the charges, and it's inversely proportional to square of the distance between them. Clear? Any doubt? Any confusion? So you can note down. Okay. Yeah. Now, if Q1 and Q2, let's suppose Q1 is positive and Q2 is negative, then this force, it will be force of attraction. Force of attraction. And vice versa. And vice versa. Clear? Okay. Now, if both the charges, let me give another example. If they are of, you can say Q1 is positive, Q2 is negative. So they will attract each other. They will attract each other like this. Okay. So this is Coulomb's law of, basically it's a Coulomb's law of force between two charged particles. Okay, so you can note down all these statements. According to this law, magnitude of electrostatic force acting between two point charges. So we need to focus on this point, that it's applicable only for point charges, and it's directly proportional to product of charges and inversely proportional to square of the distance between them. This is called inverse square law. Clear? So now let's move forward. Now let's try a couple of questions based on this concept. Yeah. So first question is, when the distance between two charged particles is halved, the force between them becomes option A, option B, option C, and option. So let me solve this question for you. So now, if there are two charges, Q1 and Q2, Q1 and Q2, and the distance between both the charges, it's D. So we can say initially force was, that is K times Q1, Q2 divided by D square. Now distance between both the charged particles, it is halved. It is decreased, and we already know force is inversely proportional to square of the distance between them. So now final force, it will be again K, charges, both the charges are same, Q1, Q2 divided by distance, new distance, and new distance is D by 2 whole square. So it will be 4 times K Q1 Q2 divided by D square. So clearly we can see final force, that is FF, it's 4 times initial force. If distance between both the charges is halved, so force will be 4 times. Okay, so basically this formula is given by Mr. Coulomb. Okay, and most of, basically all the formulae So they were derived by using data from experiments. So basically, these formulae they were derived because of number of experiments many scientists they have performed. Okay, so you can note down this question. Okay, so now let's try next question. Yeah, our question is if each of the 2-point charges are doubled and their distance is half, force of interaction becomes n times, where n is. So now you can try this question. Sorry. So there are 2 charges. Okay. So first is it's Q1, second is Q2. Now, initial distance between both the charges is how much? It's d. Okay. So initially, this was the condition. And finally, so distance between both the charges, it is reduced to half of the initial. And charges are doubled. So new distance is d by 2 and charges twice of Q1 and twice of Q2. So we can say initial force was, that is K times, where K is constant of proportionality. We will discuss about it later. Okay, K times Q1, Q2 divided by D square. And final force is how much? K constant is same. Now charges are doubled. So we can see it's 2 times Q1 into 2 times Q2 divided by D. D is halved. New distance, that is D by 2 whole square. Clear? So we can see final force, it will be 16 times K Q1 Q2 divided by D square. And from here we can see final force between the charges, it's 16 times force that was between them initially. Okay, so the value of n is how much? 16. So basically it's a integer type question. So answer of this n is how much? 16. You can note down. Any doubt, any confusion so far? Clear? Now let's move forward. Yeah. So basically, so this is the entire statement, or we can say entire Coulomb's law. So the 2-point charges, electric charges, Q1 and Q2 at rest, separated by distance r. We can see here. We show its distance r, or you can represent by d also. Okay. So now, so they will exert a force on each other. Means, let's suppose Q1, Q2 both are positive. Okay, so Q1 it will repel Q2 by, let's suppose the value of force is capital F. Same amount of force Q2 will apply on Q1 also. Magnitude will be same. Yeah, direction will be opposite, but magnitude will be same. And the magnitude of force F is given by this formula. That is K times Q1 Q2 divided by R square, where K is the proportionality constant, and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. So you can derive unit of K from this formula also. Sorry. Yeah. So from here we can say value of K, it will be equal to force into R square divided by Q1 Q2. So we can say unit of K, it will be the value of force is, sorry, unit of force is Newton. So Newton meter square. Why? Because R, it's a distance, or we can say its unit will be meter. So meter square divided by Coulomb. Okay. So you don't need to remember everything. You just need to remember this value of K. Okay. And the formula. Okay. And we also call this Coulomb's law, that is Coulomb's law of electrostatic force. Coulomb's law of electrostatic force. We also call this force as electrostatic force. Why? Because right now we are observing all the charges when they are at rest. Clear? So when the two charges Q1, Q2 both are at rest, so they will apply a force F, and its value is given by K times Q1, Q2 divided by R square, where K is the proportionality constant. Okay. Now further we will discuss about the exact definition of K and its exact value. So far, is there any doubt, any confusion? Yeah. Okay, so now let's try next question. The question is, two similar and equal charges repel each other with force of 1.6 Newton when placed 3 meters apart. Now we have to find strength of each charge. Option A, option B, option C, and option D. We have to use formula, is K times Q1 Q2 divided by D square. So you can use R also at the place of B. I'm just giving you 10 seconds. You can solve this question. Okay, now let's solve the question. So basically, force, the value of force, I'm repeating same formula again. By T square. So force value is 1.6 Newton, and value of K is how much? 9 into 10 is power 9 into charges, and both are similar. Both are similar and equal charges. So now let's suppose Q1, Q2 are equal to Q. So we can write Q square divided by distance is how much? 3 meters. So we can write 3 square. Q, its value will be equal to how much? 1.6 into 9 divided by 9 into 10 is power 9. Okay. So when we will take under root, so it will be equal to, so we can remove this point by 10 in the denominator. So it will be 4 into 3 divided by 3 into 10 is power 5. So answer will be 40 microcoulomb. So answer is A. Answer is A. Clear? Any doubt, any confusion? Okay. So now let's try next question. Yeah. So basically, initially you have to write this formula again and again. Okay. After some time, you will be very habitual. So after some time, you can calculate all the answers directly also. Okay. Yeah. Next question is F base G and F base small a represent the gravitational and electrostatic force respectively between two electrons situated at some distance. The ratio of Fg to Fe is of the order of. option A, option B, option C, and option E. So I'm giving you 15 seconds. You can try this question. So if you can write formula for electrostatic force, that is Fe, it will be K times Q1, Q2 divided by D square. Similarly, I can write formula for gravitational force. It is capital G M1 M2 divided by D square. And we have to find ratio. So F, let me use different color. Yeah. So Fg divided by Fe. So you can see D square will be cancelled directly. So now we have to write G M1 into M2 divided by K times Q1 Q2. Clear? Okay, so now you can put value of G, mass of electrons, both electrons. Okay, charge of both electrons, that is same, and value of K. Okay, so finally you will get answer. Answer will be D. So I will not solve this question for you. So you can put all the values and you can calculate it. Okay, so far is there any doubt, any confusion, or everything is clear? Okay, let's try next question. Yeah. So question is, there are two charges, +1 microcoulomb and +5 microcoulomb. The ratio of force on them will be. Option A, B, C, and D. It's a good question. You can try this question. Okay, now let's suppose the two charges are, okay, yeah. So we can see both the charges, they're having same polarity, okay, and values 1 microcoulomb +1, second is +5 microcoulomb. Now they will repel each other by same force, but in opposite direction. But we have to find the ratio of force on them will be. Ratio will be same. Sorry, ratio will be 1 because forces are same. Okay, so its value is given by K times Q1 Q2 divided by D square, and again its value is same, K times Q1 Q2 divided by D square. Divided by D square. Okay, so the ratio of forces on each other will be 1. Any doubt, any confusion so far? Clear? Okay.
When you strive for excellence, you can't settle for mediocrity. So to succeed in any competitive exams, you need to have an expert mentor, best designed syllabus, test materials, and someone who cares for your career just like you. Welcome to Regis, where our programs are designed and executed by the IITians. Enroll your board now because we believe in nothing but the best.